Okay, so this is the 8E handout, and we started by reviewing that 45, 45, 90 idea. So remember, we've this is actually the basic version of the triangle. You got a 90, you got a 45. Turns out the other angle has to be 45 as well, so you know it's isosceles. And so since it's isosceles, the two congruent sides, this one's 1, so this side is 1. And then if you do Pythag, 1 squared plus 1 squared equals c squared, you end up with root 2 for that side. And really, I strongly suggest that you memorize that triangle right there. The 1, 1, root 2, 45, 45, 90 triangle. In fact, it's called the 45, 45, 90 theorem. That's if you have this triangle, the sides are in a 1 to 1 to root 2 ratio. Okay, that's how common it gets used. Okay, so let's take a look at 2. So notice it's a 90 here and a 45 there, so this one has to be 45. And if I draw my little basic 45, 45, 90 triangle here, it's 1, 1, root 2 for the hypotenuse. So I'm basically just flipping this guy over right there. Let's see then. Notice this triangle, instead of 1, it's 10. So it's a scale factor of 10 to get this guy. So it's going to be 10 here and 10 root 2 there. And then you don't have to do any other work. So it's pretty quick if you memorize it. Otherwise, you're going to have to do 10 squared plus 10 squared equals c squared. You get root 200. And then you'll have to simplify the root. So this way you can avoid that. All right, so in the second one, let me draw here. Now, we know that the two angles here are the same, and that's 90. So you're left with 45 and 45. So it's a 45, 45, 90. And we know that the basic 45, 45, 90 is 1, 1, root 2. So in this one, it's x and y are like your 1s. So this is really the same as x. 7 is like the root 2. So we'll set up a ratio. I'll do the big triangle over the little triangle. So 7 goes with root 2 the same way that x goes with 1. So if I cross multiply, I got 7 equals, well, actually, x over 1 is x. So this is 7 over root 2. So, and we know x and y have to be the same. So there we go, right? 7 over root 2. Now, if you were taught that you have to get roots out of the denominator, the way to do that is actually to multiply the top and bottom. It's to multiply by 1, but to do it in a way where you're using the same exact root over itself, because the bottom, root 2 times root 2 is just 2, and the top is 7 root 2. So this is also x and y. That's the same thing as 7 over root 2. I don't really care right now which one you do, so I think that one's easier. Some books tell you always get the root out of the bottom, and other books don't care. So, and it turns out you get the calculus. Sometimes you want the root in the bottom. So I'm not going to be picky about that for now. Occasionally I might ask you to do it just so that I know you know how. Okay, so then the next one here. We got A as the center point of this circle, and we got a right angle there. Since it's a circle, and A is the center, that's a radius, and that's a radius. And since they're both the radius, they have to be the same length. So then you know this one's got to be 4 root 6. So you know it's isosceles, which means these angles are the same, which makes them 45 and 45 because the middle is 90. So let me draw my basic one, 45, 45, 90. Whoop. So this is 1, 1, root 2. The 1 is like the 4 root 6. Right? So if I call this side x, 1 goes with 4 root 6, the same way that root 2 goes with x. If you cross multiply, you get x is 4 root 6 root 2. So x is going to be 4 root 12. And root 12, we can simplify. That's like root 4 root 3. Well, root 4 is 2. So this is 4 times 2 times root 3. 4 times 2 is 8. 8 root 3. So this side over here is 8 root 3. Okay. Let's take a look at the next page. So that's the 45, 45, 90 theorem. The key is always remembering that triangle. There's another one that gets used. The next most common triangle that you come across all the time is a 30, 60, 90 triangle. One with 30 degrees, 60 degrees, and 90 degrees. So I actually gave you this problem back in the first semester, but I don't expect anybody to have remembered the result. The idea is if the short side is 1, you can come up with the other two sides. And so in this one, the way you do it, the way you come up with it is if I duplicate that triangle right here, then this side is going to be 1 also. This angle is going to be 30, and this angle is going to be 60. And the big triangle is 60, 60, 60. It's equilateral. So these sides are 2 because the whole bottom is 2. Right? If you look at the big triangle, all the sides have to be the same. So then to get the height, I can now get rid of this stuff. I know that this side is 2 over here, so then to get this, I'll just do Pythag. So 1 squared plus b squared equals 2 squared. So that's 1 plus b squared equals 4. So then b squared equals 3. So that means b is going to be root 3. So that's what we get right here, root 3. Okay, so this is the 30, 60, 90 theorem. 30, 60, 90 theorem says if you have a triangle with angles of 30, 60, 90, 30, 60, and 90 degrees, then the sides are in a 1 to root 3 to 2 ratio. Now, root 3 is shorter than 2. It's about 1.7. The students often forget which side goes with which. Well, 30 is the smallest angle, so smallest side goes there. 60 is the medium angle. Root 3 is the medium side. 2 is the hypotenuse, opposite the biggest angle. Okay, so again, it's important to memorize this 30, 60, 90 because it just comes in handy a ton. 1 opposite the 30, root 3 opposite the 60, 2 opposite the 90. If you remember this one, this is also a super common one. So let's take a look down here at number 4, and we're going to use this theorem. So let me draw a basic 30, 60, 90 triangle. So here's the 30, here's the 60. The short side, so remember the sides are 1, root 3, and 2. The shortest one is 1, so it's opposite the 30. The medium one is root 3, so it's opposite the 60. And the long one is 2, so it's opposite the 90. And then if you look over here, I drew it like part A, that way that's oriented. Well, I've got a 90 and a 30, so this one's 60. Okay, so the 6 in this picture is like the 1 in this one. And so really to get from this triangle, from this basic triangle to the one that I'm working with, it's going to be a scale factor of 6. So if I just multiply everything by 6, I'm done. So 2 multiplied by 6 is going to be 12, so that's y. And root 3 multiplied by 6 is going to be 6 root 3, and then you're done. Now, if you don't like that, you can set up proportions too. You can say, oh, 1 goes with 6 the same way that 2 goes with y, and then you can cross multiply and get 12 is y. And you can say, oh, 1 goes with 6 the same way that root 3 goes with x, and you get 6 root 3 equals x, and then you're done. Okay? So in part B, let's draw the 30, 60, 90 triangle, the basic one, so it looks like this. So here's the 60. This one's got to be 30. And remember the short side 1, the medium side root 3, the long side 2. Short side opposite smallest angle, so 1 goes here. 60 here, so that's the medium angle. Medium side is root 3. And then the 90 goes with the 2. Okay, and this one's a little bit weirder. In this one, the 10 goes with the root 3. So this one I'm going to set up proportions because I think otherwise it gets a little weird. So 10 over root 3 is 10 goes with root 3 the same way that x goes with 1. Okay, well, that means that x is 10 over root 3. Right? X over 1 is just x, so there's x, 10 over root 3. And y, so 10 over root 3, so this 10 over that root 3 is the same as this y over that 2. So if I cross multiply, I get 20 equals y times root 3. So 20 over root 3 is going to be y. And if you wanted to get those roots out of the denominator, I'll just do the 10 over root 3 one. You would have to multiply by a form of 1, which is root 3 over root 3, and you get 10 root 3 over regular 3. So that's also x. If you did it with y, you get 20 root 3 over 3 is y. All right. So then a couple more problems that practice these ideas. So notice the top triangle here, it's a 90 and a 60. So this is going to be 30 degrees. So we got a 30, 60, 90. So I'll draw one that looks like it. So 60, 30. The short side is so remember 30, 60, 90 is 1 root 3, 2. So the 1 is the shortest. The root 3 opposite the 60, and the 2 opposite the 90. Then down below, notice the 90 and the congruent angles, which actually make these guys 45 and 45. So we're going to end up, after we use the 30, 60, 90, we're going to use the 45, 45, 90. So 90 there, 45. Whoop. Let me draw this a little bit better. 45, 45, 90. The most basic 45, 45, 90, 1, 1, root 2. Right? Actually, let me leave this alone for now. Let's just work with the top triangle. So in the top, let's see, the 9 root 3 goes with the root 3. So you might be able to tell, well, just take the triangle, the basic triangle, multiply it by 9, and you get the big triangle. So then this side would be, so to get from here to here, your scale factor is 9, or 1 to 9. So the 1 over here turns into a 9 right there, and the 2 over here turns into the 18 right there. If you don't like that, then let's set up a proportion instead. So I'll call this y, and this one z. So 1 over z is the same as root 3 over 9 root 3. Well, the root 3's cancel. So I've got 9 equals z times 1. So 9 equals z. So that's how we get the 9 using proportions. And then the y, we've got 2 over y equals root 3 over 9 root 3. Root 3's cancel, and then 18 ends up being y. So that's how we get the 18 there. So let me just mark it up so that the 9 is here, the 18 is here. Okay, and then let's ignore the top part of the picture. We need the bottom part. We need that x right there. Well, let me draw the 45, 45, 90 basic triangle. So this one's going to, in a 45, 45, 90, remember the sides are 1, 1, and root 2. 1 shorter than root 2. Root 2's got to be the hypotenuse. So in this case, the 1 is like the x, and the 18 is like the root 2. So I've got x goes with 1 the same way that 18 goes with root 2. Well, then I'm done. X is 18 over root 2. Now, if you wanted to get rid of the root 2 at the bottom, you're going to multiply by root 2 over root 2. So this is one answer, by the way. And if you did that, you get 18 root 2 over regular 2, which turns into 9 root 2. So there's another form of x. These guys are the same. All right, and then let's take a look at the very last problem. This one's tricky because it doesn't look like you can use 45, 45, 90 or 30, 60, 90, but it actually turns out you can use both. If I chop right down here and make that a right angle, then I've got 45, 90, and some angle up here has to end up being 45. And then if you subtract 105 minus 45, you get 60 over here. And now I've got 60, 90, this one has to be 30. So it turns out you can actually chop this triangle into a 45, 45, 90 and a 30, 60, 90 triangle. So let's take a look at the 7 root 2 side. So this is 7 root 2. And if I draw in a basic 45, 45, 90, remember the sides there are 1, 1, and root 2. Well, the 7 root 2 is like the root 2. So you might be able to tell just multiply by 7 to get this triangle on top. So that means that the 1, if I multiply by 7, just turns into 7 and 7. You could set up ratios too if you prefer that, but I think that's easy enough. So this side's 7, this side's 7. Now the mistake a lot of students want to do now is they want to say, we'll use the up-down theorem. 7 over 7 equals 7 over this side right here. You can't use the up-down theorem because the big angle on top is not a right angle. Okay, so you got to figure out another way of doing it. So that's why over here we'll use the 30, 60, 90 theorem. Okay, so this is 7, this is x. This part right here is not y. It's, I don't know, let's call it z, because y is the whole thing. So we'll figure out what z is, and then we'll add it to 7 to get y. Okay, so I'll call this one z. And if we draw a basic 30, 60, 90, remember it's 1, root 3, and 2. 1's the short side, root 3 is the medium side, 2 is the long side. So you might be able to tell, well, to get from my basic triangle to this triangle, I have to multiply. I also use a scale factor of 7. So x is 2 times 7, which is going to be 14. And z is root 3 times 7, which is going to be 7 root 3. And then I'll put that up here. So this guy right here is 7 root 3. X is 14. And so if we put this together, 7 plus 7 root 3 is y. So x is 14, and y is 7 plus 7 root 3. And you can't add that to get 14 root 3. You'd have to have 7 root 3 plus 7 root 3 is like having 14 root 3s. So it turns out that's actually as far as you can go. So these are our answers right there. Okay, I hope that helps a little bit, and I'll see you guys soon.